Today in Algebra 1 in section 2.1, we are going to talk about integers and rational numbers. Real numbers can be broken into two subgroups, rational numbers and irrational numbers. Today's lessons will only contain rational numbers. Rational numbers are any numbers that can be written as a fraction. Okay, so in the subgroup of rational numbers, we have integers as well as whole numbers. So let's take a look at what the difference of these things are. Whole numbers start with the number 0, and they're whole. They cannot contain decimals or pieces of another number. So we have 0, 1, 2, 3, and so on. Okay. Integers, on the other hand, are whole numbers and their opposites, which means that they can be negative. So we could have -3, -2, -1, 0, 1, 2, 3. Okay, in this case, just like with the whole numbers, we can't have a piece of a number or a part of a number or a decimal of it. It has to be a whole number or its opposite. Those are integers. Okay, and then when we look at rational numbers, a rational number is any number that can be written as a fraction, 1/2, 2/3, anything like that. Let's take a closer look at the vocabulary that we spoke about on the previous page. Whole numbers, integers, and rational numbers. And let's put it in terms of a social club. We're going to say that whole numbers started a club, and in their club, they started with the number 0, and they didn't want any pieces of any numbers. They only wanted the numbers to be whole. So they just started with 0 and had 1, 2, 3, and so on. So that is the whole number group. Well, those members got together and decided that they wanted to keep the members that they had, but they also wanted to add their opposites, which are their negatives. So they kept the numbers that they had, 0, 1, 2, and 3, and so on, all the way into infinity. But then they wanted to add their negatives, -1, -2, and so on. So the integers added into the group the whole numbers opposites. So integers can contain negatives where whole numbers cannot. Then rational numbers wanted to join the group. The rational numbers said, okay, if the number can be written as a fraction, can we join the group? And so the whole numbers and integers got together and said, sure, you can join the group as long as you can be written as a fraction. So rational numbers are any of these numbers, whole numbers or integers, that can be written, and anything else that can be written as a fraction in the form of a over b. Now a over b have got to be integers, except b cannot be 0. b cannot equal 0. Why not? Because 0 in the denominator is undefined. So we can have any two integers that we would like to have, positive, negative, doesn't matter, as long as the denominator is not 0. So the rational numbers contain all of these, the whole numbers and the integers. Okay, here are two more vocabulary words. Opposites. Exactly what they say. What's opposite of positive? Negative. What's opposite of negative? Positive. Therefore, if we say, what is the opposite of -75? Its opposite would be positive 75. It is that simple. Opposites. Absolute value. Absolute value is the distance a number is from 0. So when we talk about distance, we know that a distance always has to be positive. Even if you have a number line, and here is 0, if we put 3 right here and -5 right here, the absolute value of 3 is 3 because it's distance from 0. It is 3 units from 0. Okay, the absolute value of -5. Absolute value is denoted by two straight bars, one on each side of our number. The absolute value of 5 is also a positive number. It's 5 because it is its distance. Distance always must be a positive number. And how far is it from -5 to 0? Well, it's 5 units. Therefore, it must come out to be a positive number. The absolute value of a number is always, always, always positive. So that's one of the few times in math that we can have an always statement. The absolute value of a number is always positive because it is its distance from 0, and distance must always be a positive number. If we have this list of numbers, 1.6, 1, -4, and 0, and the instructions say to tell whether each number is a whole number, an integer, or a rational number, and then order the numbers from least to greatest, we can say, okay, no worries, we can do that. 1.6, 1, -4, and 0. I listed them vertically for just a second so that we can group them easily. Okay, let's start with rational numbers first. Remember, on the first page, we said everything that we were going to look at today was going to be a rational number. So yes, each one of these is a rational number. I'm putting an R next to each one of them to indicate that yes, those are rational numbers. Now let's go to an integer. Which ones of these are integers? Remember that integers are whole numbers and their opposites. Okay, 1.6 is not an integer because integers cannot have any pieces, no decimals or fractions from them. Okay, is 1 an integer? Absolutely it is. So we're going to write an I for an integer. Is -4 an integer? Absolutely it is. Is 0 an integer? Yes. Okay, remember that integers are whole numbers and their opposites. Okay, now which one of these are whole numbers? 1.6 cannot be a whole number because it has a decimal with it. Okay, is 1 a whole number? Yes, it is. It starts with 0, 1, 2, 3, 4. Is -4 a whole number? No, it is not. Why is it not? Because whole numbers cannot be negative. Is 0 a whole number? Yes, it is. Because whole numbers start with 0 and go 1, 2, 3, 4 on into infinity. Now the last thing it says to do is to order these on a number line. We can put them on a number line from the least to the greatest. So if we have this number line, and we have 0 right here, and we'll have 1 here and 2 here, and then we'll have -1, -2, -3, -4. Okay, well, let's put these points on here. -4 is the furthest most to the left, so it is the least. Okay, so we've done -4. The next number that we will find on the number line is 0. So that's the next largest. Okay, then we'll go to 1 and 1.6. 1.5 would be halfway in between 1 and 2, so 1.6 is just a little bit past halfway. And then we'll just draw this arrow straight down right here, and we will put 1.6 as to not clutter up our graph too badly.